you, but just in case, Kevin Joyner. I am a lecturer in the computer science department. We're now teaching CS 215 and 211. And so what I'm going to talk about today is I just started back in August, but what was I doing the previous 9 years before I got here? So this is basically just a little snapshot of what I was doing, the type of thing I was doing. Okay, and so let's get started then. First, let me thank you all for coming, because I just saw in the news last night where the Office of Student something had a speaker. We're all, 30,000 now? UK students were invited, and out of 30,000, one showed up, so I think I'm doing pretty good. At least 4 or 5. So thank you for coming. All right, so a quick overview for some terminology so that we can sort of answer Dr. Finkel's question that he just sort of posed. Then we're going to take a look at the software development lifecycle as it applies to data migration. It's just slightly different. There's some slightly different concerns and certainly a different distribution of effort there. Take a look at some common issues, some problems that we seem to always run into. Okay, and then we're going to focus on, what kind of skills does someone who gets into this area sort of need, because the technical side is only a part of it. And finally, some career opportunities. I just went out on Google and just to see what jobs are available besides the one that I knew about. And I was going to have a list of in Lexington and then the list of else, but I found so many in Lexington, I just ended up without this. So that's where we are headed. Okay, first a little bit of terminology to clear things up a little bit. The general definition of data conversion would be any process of translating data from one computer representation to another for any reason. So this is what Dr. Finkel was talking about. He's always converting things. So that could be like converting a Word document to a text file or something like that. So, but the kind of the point of what I'm talking about is a little more specific. Okay, data migration just talks about transferring data between file storage types or file formats. That's a little bit closer to what I'm talking about, but we're going to narrow it down even a little bit more. All right, and so what to narrow it down, take a look at this word or this phrase, application migration. And here is the general idea is we have this computer system that we've been using for 5 years, probably more, 10 years, 15 years, 20 years. How long do you think most computer systems are in use?
30 years.
Is that?
30 years.
It could be 30 years, right? Some of them are fairly old. One of the projects I had, or clients I had briefly because I decided not to do the project, about 5 years ago, sent me the information for an estimate, and I asked him, what system is this running on? A VAX 11750.
Great machine.
Exactly. Even in the year 2012. And I was just amazed, because I don't think they've made those since when, about 1989. And I said, where do you get parts for that? And he said, oh, we don't actually have a VAX anymore. There's a company that makes emulation software that will turn your Windows server into a VAX machine. And so that's what they're using. So yes, those applications go way back to the 80s, and they're still using them. And that was a fairly large client, a Cincinnati-sized city, their police department, still using their old 1980s technology. But at some point, they finally decided what we want to do is go to something new and modern, all right? And so the general description of application migration is basically that. We want to go to a different application, but just because we're going to a new computer system doesn't mean that we can throw away 30, 40, 50 years of data. Okay? Now, and that's often, though, when you go to a new computer system, is going to involve at least some change to their business process. And sometimes they don't even realize that when they make the decision to go to a new application. All right? Yeah, so real basic idea here, this little diagram is of what data migration is here in this context. Is you start out with the database of this legacy system, and we're just going to convert it to the database of the target system. So when I first started getting into this, I thought, well, how hard could it be? It looks fairly simple, right? But as I found out that it's actually sometimes it's more like this, okay, with these ancient systems that we have to convert into something new, okay? So have all of you had a database course yet? How many of you have had databases? Okay, So how many of you know what is first normal form? Okay, I've dealt with databases that aren't even in first normal form. Okay. Again, most of them designed back in the 1980s. So sometimes it involves going back to the very old technology, very old ideas, or very poorly designed ideas, and trying to bring those into something new. Okay. All right, now, so once we get right down to the nitty-gritty, though, this is really our target, okay, of the work that we do is to create this mapping. So, sort of the idea in the little picture here is that there is a database schema of the legacy system. And frankly, if that actually exists, it's a miracle. Okay, if there is a schema that looks like that. Usually one of the first jobs we have to do is we ask the client for this sort of thing. They say, oh, all we've got is a backup of the data, text files. Here you go. And that's about all the information we get. Okay. But somewhere in there's probably a schema we have to figure out. And then the idea is to map that sort of field to field, table to table, to the schema of the new, latest, and greatest application. All right, so I thought I would take a look at a little bit about software development lifecycle. So, there are two big ones we usually talk about these days. One is the waterfall method. And when I first got into this, that is what we were still using. Okay, found out there were some problems with that, and fortunately have changed. All right, now this data I had to footnote it, 1990, so it's probably been updated. When I went out and looked around for this sort of data, it seems like everybody has a different opinion. But just to throw it up there, on a typical large software system, where do we spend our time? Most of it's on maintenance. That's sort of the point. Okay. Any of the changes that are made after is quote unquote done. So, yeah, okay. This is based on completely and totally unscientific data, guesstimates by Kevin Joyner, all right? Where do we spend our time, most of our time? And if you look, it's almost all on analysis and design. So if you're one of those people who just loves to spend 60 hours a week writing programs, then this is probably not for you, okay? Because coding only takes up, I would say, depends on the project, 25 to 30% or so. Okay. Most of the time is spent on analysis and design. Now I added a couple of extra phases to this waterfall. First is estimation of effort, because that always seems to preclude everything. Clients seem to be amazed at how expensive this is and how much work it takes. Okay, they decide, hey, here's this new great system for running or managing student classes. It's called Canvas. Compared to our old stuff, it's great. Okay, but then when they find out if they have a lot of data, 20 years of data, they got to pull all that over. It might take some time and cost a little bit of money to do that. Okay, so the first thing they always want to know is how much is it going to cost and how long it's going to take. And then the other thing I added, because it's an important piece, even though both of these are only small percentages, is the actual execution of the software to go live. So one of the big differences between the conversion software and your typical everyday application is you spend all of this time doing these requirements, this analysis, this design, a little bit of time coding and testing, and you execute this program once and throw it away, never to be used again. That is sometimes how it is done. Now, of course, what we try to do is do a little reuse. Okay, things are broken down into modules, and if we can reuse a module from an old project and a new one, we can. But very often, that's what happens. So just that aspect of this software development is what makes it a little bit different than your typical style of development. Okay, now, so just going through the waterfall real quick. Okay, for this estimation, usually what we're just given is a copy of the database. Again, if we have any sort of documentation, that is a miracle. Okay, but here's a copy of our data. And if they have any documentation, they'll give it to us. And of course, we usually know a little bit about our target database. Okay, there are various different kinds of companies, organizations, situations that what you could call data conversion. But very typically where they'll be employed is, okay, we work for a software development company that makes this great software product, and they just have their little team, hey, when we get a new client, we need to have that new client's data converted. Okay. So in that case, usually the conversion analyst is very familiar with the target database. Not always, but sometimes. Okay. So they send us this data and want to know tomorrow, how much is it going to cost to do this project? So we usually don't have a lot of time. So we kind of base it on a number of tables, all right? So how many tables do you want to convert, how many fields are in there, and the cleanliness of data. Okay, we're going to see in a second, one of the big issues that we run into is dirty data. And one of the operations we have to perform is data cleansing. All right, so requirements, and I only put like 2% down because I'm hearing the official requirements. We always get the same 2 requirements. 1, migrate our legacy data to the target database, and 2, make sure it will go fast enough. Those are our requirements to start off with, okay? And later, as we go through the process, we may add some detailed requirements, but usually that's what we start with, just those 2. Okay? Now, and remembering then, the user is usually a data conversion specialist. So that's one thing that makes these much simplified pieces of software is we don't have to write a user interface, okay, or one that's complex at all, because the person, if I'm writing the code, I'm doing the project, the person, the one user for this software is going to be me. So I just have to make me happy, and that will be sufficient. All right, analysis and design. So this is where we spend all of our time, okay, is taking a look. First, we start looking at the database itself, and then we're going to find these issues, these questions. And we're going to go to the client and ask them, well, what about this? Okay, what does this mean? Right? A lot of times we have to look at the data. That's where the data cleansing comes in, and find out that, oh, well, that data is, we don't need that, or it's incorrect, or, okay, we're going to have to do something to get around it. But very often what we do is I find an issue, then they usually come up with 2 or 3 options on what they can do, and then I present it to the client and ask them, and give them the pros and cons of each one, and ask them which option do they want. And guess what the answer usually is?
Just starting the day up.
That's a good one, but no, it's like, we don't know, that's why we hired you. That's usually the answer. You're supposed to figure this out, which, but I'm not going to have to live with this decision for the next 10 or 15 years. So a big part of the job on that is, trying to clearly express to non-computer people, in my case, they're lawyers and judges and court clerks. The system I worked on was all judicial type data, and try to explain to them, okay, why I need this decision made, and what are the implications and impacts for them.
You have a question over here.
Oh, was there a question?
Yeah, so I'm the police department, and you're saying, like, do I want my data this way or that way? So, like what could the different ways be? Like, how could what are your options?
What we're talking about here for the police department was they're using an application that was written in the 1980s. Okay, so they're using DOS. That would actually be maybe an advancement to say they're using DOS, if you know what that is. Okay, and now they want to shift to Windows 10 as an operating system, but really they want to shift from something some college student wrote in the 1980s to say Canvas. So you all are familiar with Canvas, right? So that is an example of maybe a university student management system. Okay, so that is sort of what we're talking about here. So I'm not sure if that answered your question.
So you asked me, what do I want to use Canvas or do I want to use Blackboard? And I tell you, I don't know, you pick.
No, it's more like you're already using Blackboard, but you decide that that's old junk and you want to move to Canvas.
So I think the question here is, what's an example of one of these, a place where you present multiple options to the client?
Right, okay, so an example would be, in your old system, and there's another slide that will point this out, very often these old legacy systems do not enforce a lot of rules on what you can enter for data. So, for example, on one system I had, the legacy system was a name of the 4th guardian ad litem attorney. Okay, apparently there could be 4 on a case. And the system would not enforce. You could type in anything you wanted to in there. Okay? Now, the new system, the target system we're going to, you have to pick an attorney off the official attorney list. Okay, so if they're not on the official attorney list, they can't populate that field for the attorney. So, one little piece of analyzing the data is, all right, we'll find attorneys that aren't on the list. And so I do this, and we come up, there are attorneys named Big Mac, Fries, and Coke, Sub Club, Barbecue Chips, and Pepsi. And like, I have to go to them and ask, what do you want to do with this? Okay, and it's like, oh yeah, that was old Judge Johnson back in the 90s. He knew how to use our, written back in the 80s, computer system, but he didn't know how to use email. So what he used to do is whatever case they were working on, if it was going late towards lunchtime, he'd put his lunch order in the GAL attorney name number 4, because they never had 4. And his secretary would know to get on the computer and go get his lunch order. Okay, so what do you want to do with this data? Well, you can throw it away, but especially with court data, you better get that in writing. Okay, so we might say, well, we could transfer that to a note. Can't put it in an attorney. Okay, I guess one option would be to actually go and enter in the attorney's list, Big Mac, Fries, and Coke, but that doesn't sound like a good option. Okay. So that's kind of a silly example, but that was a real life example. More often it is, okay, we have to do some sort of conversion of this data, and we found some records where there's bad data. Okay, what do you want to do with those? We can try to fix them, we can throw them out. We can replace data or make assumptions, that sort of thing. And then tell them what are the pros and cons of doing all those things. So did that answer it?
Yeah, that's exactly what I was asking. Thanks.
Okay, thanks. Okay, so at the end of this analysis and design, what we're after is that, with that little picture I showed you earlier, is that schema mapping. All right? Coding. The coding, once we get that done, I always felt like once we got that design made, then the rest was easy. The coding part is usually fairly easy. And so I just want to point out here a very common term we use a lot here, ETL, and then you'll see on any of the web pages or job offerings or those kinds of things. And that just means extract, transform, and load. So it's pretty simple. We take the data out of the old system, we have to do some kind of transformation on it, and then we load it into the new system. A big part of that is usually identifying and reporting records that are rejected because there's something wrong with them. Okay, they've got an attorney name that's not on the attorney list, so I can't convert that because the new system won't allow it. And then to point out that very often the unit integration testing is done by database queries. So again, this conversion software doesn't have a user interface. There's no pretty screen with buttons. Okay, this is going to be a data conversion analyst who's just going to load this thing up and press go on the night of go live. The night that we're actually going to do this. So that means if we don't have nice pretty screens to look at least in the beginning, then we have to use some database queries to do that. Now, but eventually we do have to get around to verification. So the user acceptance testing involves comparing the data, what's on the old system to the new system. So just exactly what you would think it is, okay? We have the data moved. Of course, we're using test systems here. And on this computer or in this window, I've got what it looks like in the old system, and on this computer, this window, I've got what it looks like in the new system. And that's very much spot testing, okay? But that's what the user wants to see. Now, they have 15 million records. How many of those are they actually going to check? Maybe 10. And based on those 10, say, yep, it looks good to me. So we usually have to end up helping them try to figure out, 10 or 20 examples of what to look at. All right, and then execution go live, that's the big night. So we usually do this on off hours. I always knew that if it's a 3-day weekend, that I would have to work, especially when I was working with one client. Because, of course, we can't shut down the whole judicial system to do a computer thing, or even an afternoon. So Friday, the courthouse closes at 5. That's when my weekend starts, or our weekend would start. And then we would do it on MLK weekend, or Memorial Day weekend, or Labor Day weekend. So we'd have 3 days just to get it. So what happens is pretty simple. We're going to shut down the old client system so nobody can be making changes and adding stuff. All right. Then we're going to execute these conversion programs, which hopefully, if they're fast enough, they'll get done before the weekend is finished. And then finally, once it's all moved over, then we'll bring up the new system and hope everything works just like it did during system testing. Okay, so went into maybe a little bit too much detail on that, but that's basically what the waterfall method we had to do. Question? Oh, question.
So what happens when you have cases where, say, it doesn't finish transferring data over the window that you're allotted?
As in it doesn't transfer because it failed?
Well, more thinking like if it takes too long to finish transferring data, what happens in those cases?
Yeah, and usually, we will do, timing tests to make sure that it will go on time. But I have had examples. Of course, all these tests are done on test systems, right? And then you have the production system, the real system. And so one time we did have this problem because on the production system, their DBAs had a recording mechanism. Everything that happened on that database in excruciating detail was recorded in a text file. And of course, writing to the text file takes time. And so with that recording turned off in all our test systems, the program is maybe running in 30 minutes. Then when we go the night of go live, and everything's supposed to be done tonight, right? What was taking 30 minutes on the test system was taking 5 or 6 hours on the production system. And so you contact the DBAs and tell them, we need to turn this off. They're like, no, that's violating our security code. So we contact the DBA's boss and say, we said we were going to have this done by Monday night. It's not going to be done until Friday. So you're going to have to shut down your court system for a week to get this done, or just not do it at all. So that's when the judge calls the DBA and says, hey, this one time, let's change the rules. Okay? Because what we're doing is basically, as I call it, shoveling data. I'm writing 10 million records. I'd like to write 10 million records a minute if I can, but maybe an hour is what it takes. But if you suddenly slow that down by having some software on the database inspect all that, it will slow down. So things like that do arise. Usually we try to head that off, obviously with testing, but something like that can throw us off. And so somebody who makes a lot more money than I do makes that decision on what would happen. Okay, so the primary problem with this waterfall method is actually the real common problem with the waterfall method, okay? And that is you go through all of these steps, and by the time you get to a certain point, the client says, oh, that's what I asked for, but it's not what I want. Okay, the user's motto. And that seems to be a very acute problem with data conversion. Why is that? Well, the clients decided to go to this new system. They really don't know anything about it. So when I asked them, okay, so we're going to take this and we could put it over here, and then it'll work this way, or we could put it over here, and it'll work this way, or we could put it over here. They really don't have an idea what I'm asking. How's it going to work or whatever. Secondly, these projects can often take anywhere from 6 to 18 months. So when you're talking to them about these things, they're like, I'm really busy, this isn't going to happen until 8 months from now, or 12 months from now. They just really don't answer the question. And one thing I had already gotten into is I would refuse to talk to a client until they had gone to training. They need to know how to at least have basic training on how to use this new system. Otherwise, they will have no clue at all how to answer my questions. Okay. And so what would happen using the waterfall model is we would go through all of that, try to elicit these requirements, try to do the design, do all this coding, do all this system testing, do all this unit testing. Okay? And we get to that point of user acceptance testing where for the first time, after 9 months of work, for the first time ever, these clients see their data in the new system. And then all of a sudden, sort of the light bulb's going on. Oh, now I understand how it's going to work. Okay? And then the first thing they say is, oh, well, we need to change it. Okay? So that was a problem that we were constantly running into with the waterfall. And so, of course, what do? You have to go back and change it and redo a lot of code. So that was a problem. All right, so what about the Agile method? The Agile method, we're going to do a little bit, and go through the whole cycle, do a little bit, go through the whole cycle, each one of those little bits. We call it sprint. Okay? So here are the major advantages. We're going to elicit all these detailed requirements early in the process. And that's sort of a big idea behind the whole Agile part is we don't want to wait until 90% of the work is done to find out, oh, that's not what we want. We want to find out these things earlier. Okay? So what we would usually do is in the first sprint is basically our team would just, we wouldn't even ask them a lot of questions. You know, we would just make up our minds, I think this is how it should be done. And they actually liked that part of it, okay? The point was do a little bit of coding, enough so that we could put it out on that new system, and then they could see it, okay? So something quick and simple. And here was sort of the point. When the client sees their own data on the target system for the first time, that's when everything goes off in their head. That's when they start to understand. That's when it's clear. Back when it's, you know, technical design documents and requirements documents and all these other documents, you know, it just goes in one ear and out the other. They really don't understand what they're looking at. Okay? But once they actually see this new system with their data in it, not just sample, for example data, but their actual stuff in it, and then they can start to imagine, okay, this is going to be my day-to-day life from now on, or at least for a very long time. Then they begin to understand and start to think about it. And then, of course, once we get that first one down, the idea is, you know, your typical Agile is we're going to code and execute some more of the conversion. We're going to demo that to the client, and then get their feedback on any requirements. And while we're going, keep analyzing that data to see if there's anything out there that is going to cause a problem. Okay, so the major drawback of this, and this is why when I tried to get our upper division management, I was working at Xerox, to do this, is they refused, they didn't want to do it, because data conversion is usually seen as a service more than it is developing software. Now, we always have to develop software to provide the service, but they would see it as a service. And that's how most people see it, as a service. We'll come in and convert your data for you. And the problem is that they would want, you know, a detailed contract, total number of hours, cost this much money, a legal document signed by the client before we were ever allowed to write one line of code. Okay? And so that pretty much goes by the waterfall method. You cannot start coding until your design, your requirements in your design are completely finished. Okay? And again, it was that problem that I mentioned earlier about if you don't have something legally signed and you get down to that user acceptance testing and I'm like, oh, redo it all. It's an extra 9 months. You know, now the length of the project just doubled. Okay, possibly. And that's going to cost money. Who's going to pay for it? Well, if you've got this legal document, it says they pay for it. Either they take what they asked for, or they pay us more money to redo it. Okay. So, trying to convince, you know, these upper level management that, hey, it would, you know, if we could write just a little bit of code, this would work much better. Took some convincing, but eventually we're successful in doing that. Now, but what is the risk with the Agile is, okay, we are going to get their ideas early, but the problem is we don't have this signed, sealed, delivered requirements and technical design documents. Okay? Because basically what we're doing by doing the Agile method is eliciting the requirements as we go. And of course the problem with that could be that the client could keep changing their mind, keep changing their mind, keep changing their mind. And we have nothing to give our lawyers so they can go to court and say, all right, you owe us more money if you're going to keep changing your mind. Okay, so that is the risk of using the Agile part.
I have a question.
Okay?
Could you not convince them to sign shorter term contracts, like monthly or something?
You probably could, but I think with our business people, with our group, you know, when you work for a larger company, their process for doing those things is incredibly sophisticated and difficult. And lawyers have to be involved, and lawyers like to make, you know, $500 an hour or whatever. So that becomes very expensive and very time consuming. Now, if you're at a smaller company where you're more flexible, you could probably do something like that. Okay. With a lot of our clients, what we do is because we go through those early phases, you know, and we get to know them pretty well, at least our business people do, and we'll find out, are they going to be one of those clients you're going to want to change things all the time? And actually, we never had much of a problem with that. While I was there, I had heard about problems that had happened earlier, but I never ran into that, so I was just lucky. Okay. So that would be a possibility if you have the time to do that. Okay, so moving on from the software development lifecycle, I thought I would mention some issues. So there's this idea of data cleansing, going through there and trying to find things that are going to cause problems. Okay, so I mentioned one earlier, the attorney named Big Mac Fries and Coke. That would be an example. Sometimes it gets very bad though, where there is just bad data. And bad data converted is, guess what? Bad data. Okay. And so I spent one project where the business person didn't ask me before he made this deal, but he made a deal for 16 hours of work, and it took me 400 hours of work. I could have told him, no, we can't do all of that in 2 days. But it turned out to be a data cleansing issue. And the data was so dirty because they just simply had wrong data. Okay? And they were living with it. They had wrong data in their legacy system, and there's no magic formula to say, oh, that's the wrong case number. Okay? Let's change it. Even though we tried hardly, we even went to the point of trying to use optical character recognition to look at written documents to try to actually pull a correct case number off. And that didn't get very far either.
Oh, sorry,
So sometimes data cleansing can be a very big part of what's going on, and dirty data can make a project fail if it's too bad.
Oh, okay.
All right, probably one of the biggest issues that I ran into while I was doing things is what's called person merging. All right, again, these legacy systems are usually not very well designed, especially from a database perspective. And the entity relationships are not very clear. So for example, on the court case, if you've been to court 18 times, and your name is John Smith, your name is in the database 18 times. That's how the old legacy system would work. Okay, and the impetus for a lot of these court systems to move to the new thing was, of course, now we want to do all these background checks, etc., to see if anyone's evil before we hire them. It's trying to find out, put together, assemble that person's criminal record. And so the problem is the John Smith on this record, the same John Smith that's on that court case. Okay, and this becomes a major problem. Now, you might say, how do you think, what would you say would be an easy solution to that problem? And this is the Kentucky way of doing it. What's that?
All of them.
Okay.
What do you think? Social security number, name and birthday, or name and address on birthday.
Right.
Middle name.
Middle name, right. So I know one horror story from before I started with my team back then was one state decided, they have the same first name, middle initial, last name, and date of birth. It's the same person. And so all of our people are like, no, that's not true, that's dangerous. You should not person merge based on just that. It's very possible that there are two John A. Smiths born on the same day, and they're not the same person. They're like, oh no, that's probably not going to happen at all. Well, so, our lawyers got them to sign all these indemnity contracts or whatever about it. If something goes wrong, we're not responsible. We warned you not to do this, okay, and you still insisted on it. Okay, well, it happened. There was one John A. Smith, born on the same day, who had gotten a traffic ticket and gone to court to fight it. Another John A. Smith, born on the same day, had been convicted of murder, spent 25 years in jail, and had been recently released. Okay, well, they had the same first name, last name, middle initial, and date of birth. So those two criminal records were combined into one person. It so happened that the John Smith who went to court to fight the traffic ticket was a judge. Judges don't like it when, as he was retiring from his judgeship and going to go get the big, multi-million-dollar job with the big law firm in New York, that they would tell him, you're fantastic, we're going to hire you. 2 weeks, you get a hire letter, and then they say, sorry, we changed our minds. And finally, he finds out why. He asked him, he said,